morning. Today we are reviewing Unit 7. So our first objective is CO51, using that protractor. Remember, using the protractor, we need to make sure we are lining up the vertex of our angle right in the middle right here. Then you look at which way the bottom line is pointing. If it's pointing to the right, you start on the right inside with the small zero numbers going up. If it's going to the left, pointing to the left, that means we go to the outside going up. So with those protractors, remember to look at which side the bottom part of that degree is pointing. So you're either using the inside of the protractor where that zero is, or you're using the outside where the zero. Always go to the zero where your angle is pointing to. So we will be using those protractors on the test just for this first objective. Vertex are where the two lines meet. Acute angle, remember, is less than 90 degrees. So acute, we need to remember less than 90 degrees. So you can write it, but you cannot draw a picture of what an acute angle looks like. You can write the definition, no picture. A right angle equals 90 degrees. And it can be shown with the square. So we know if there's a square in that angle, it is 90 degrees. Right? Obtuse angle is greater than 90 degrees. So it's those big angles. Acute, so little and cute. Obtuse are big, greater than 90 degrees. And our straight angle equals 180 degrees and is a straight line. So it's important to remember these. If it's smaller than 90 degrees, it's acute. 90 degrees is a right angle. Larger than 90 degrees is obtuse. Exactly 180 degrees. That straight line is a straight angle. So put the definitions. These are right from our objective pages. Just like in our homework, you're going to have to measure angles. Remember, it might not be exact same measurement that I get, but you can only be off by a few degrees. If you're off by more than 4 degrees, it will be wrong. So it's very important that we line our protractors up the same way. We line them up carefully so our degree is as close as possible. Next objective. CO52, complementary or supplementary angles. Complementary angles, two angles add to 90 degrees. Remember, adjacent means they share a side. So they're right next to each other, forming that 90-degree angle. So you might want to put what adjacent is in case that's on the test. It was on one of our review problems, and somebody was like, well, what does it mean that they're adjacent? So you need to know adjacent means they're sharing the side. So what that would look like, you can't write what it looks like, but that's they share a side. So we have this angle and then we have that angle. They're sharing a side. They don't have to be complementary, but if it says they need to be adjacent, you need to know that they share a side. Liam, you need to stop turning around and looking at Cam. I truly need you paying attention, hon. Supplementary, two angles add to 180 degrees. So it's that straight line. For some reason, I always go with 110 and 70. That's just my go-to supplementary angles. So complementary two angles add to 90 degrees, supplementary two angles add to 180 degrees. Adjacent, the two angles share a side. So if we're looking at these, you should be able to know if they are complementary or supplementary. If they add up to be a number that's not 90, not 180, they are neither, right? Those are our magic numbers, 90 degrees and 180 degrees. CO53. Now we start getting into the vertical and corresponding. What are those? Vertical angles, remember. Let's see what. So they share a vertex. Are opposites. Of each other and congruent. What does it mean if I say they are congruent? They are their exact same measurement. So you can put the definition, you cannot put an example picture. I'm going to draw one to remind us when we see the X. You could write, looks like an X. So you can write that to remind yourself, vertical angles look like the X. So we know this angle is opposite of this angle, so they are congruent. These two angles are opposite, they are congruent. Those are vertical angles. So they're opposite sides of each other on that X. Any questions on the vertical angles? So do we have to know what the degree measurement is? No, because remember, this arc and this arc shows that they are congruent. I could have a measurement in there. I could say it's 85 degrees and 85 degrees, but I don't need the degree measurements. I need to know that they are congruent, that they are the same. Then we have corresponding angles with parallel lines. Angles in same location on a different line. They are congruent. So remember, that's when you take the one vertical angles that we see, you lift it up and you place it on the other line. So we have our parallel lines. There's a line cutting through them. These angles are identical to those angles. So you pick up from one line, you put it on top of the other line, and they are the same measurements. So this angle matches that angle. So remember, you might just be given one angle on those corresponding angles. Use what you know about vertical angles, what you know about supplementary angles, and what you know about corresponding angles. So if this is 110 degrees, what does this angle have to be? 110, because they are right across from each other. They are vertical. They are opposite on that vertex. How do I know what this angle is going to be next to the 110? Madeline?
70.
How did you know it would be 70 degrees, Madeline?
Because it's a straight line, so it has to be
It's that straight line, so they have to be supplementary. And then if I know this one is 70, I know this one is 70 because they are opposite of each other. I can fill in that top section because they are corresponding and all of my angles will match up. Layla, your eyes should be up here, not at whatever you're staring at. It's not going to help you learn. You need to pay attention up here. So all of these angles, I can just fill in right like this because they look the exact same. So when we do those corresponding angles, you find out one vertical angles, and then you put it on top to the other parallel line. It has to be parallel lines. So in order to be corresponding angles, they must be parallel lines. Any questions on the corresponding angles? All right, let's look at our next objective. CO54. Now we're talking about classifying our triangles. Remember I said you need to know the difference between the side names and the angle names. Because on the test it might be asking what is the side name for this triangle. You might know it's an acute triangle, but if it's saying side names, I need to know it's isosceles or it's scalene. So you need to know the difference between side names and angle names. So on your help sheet, write side names, the triangle sides, scalene, all sides different. So if it's a scalene triangle, all the sides are a different measurement. If it's isosceles, what does that mean? Layla? Say it louder. Two congruent sides. And if it's equilateral, what does that mean, Marina?
Three congruent sides.
All the sides are the exact same, three congruent sides. Now, some of us are thinking, oh, I know this. I remember this. I don't need to write this down. What happens when it comes time to take the test? You forget. You're overwhelmed by all the information. That's why it's important that we write it on our help sheet in case we forget. Okay? You might say, I totally get it. I know scalene, they're all different. But tomorrow, when it's the pressure of the test, Thursday, when it's the real test, super easy to get mixed up. So when you're given the opportunity to do a help sheet, take advantage of it and write it all out so you don't forget. Second part of this objective is the angle names. If it's an acute triangle, what are our degrees? 3. So we don't need to know actual degrees, but 3 acute angles. So we know acute means there are less than 90. If we're looking at angles, what do all of the angles in a triangle have to equal? 180 degrees. So if you're putting in the degree measurements as an example, they're all acute, they're all less than 90. Remember, all 3 of them added together must equal 180. So if your example that you draw on the test does not equal 180, then you do not get credit for it. You have to remember triangle angles always equal 180 degrees. For the right triangle, we have one right angle, which equals 90 degrees. Okay, so you've got that right angle. You can show that by writing 90 degrees. You could show it by putting that box in there. Obtuse triangle, one obtuse angle. So one angle is bigger than 90 degrees. You can't have two obtuse because that won't form a triangle. So only one of them is obtuse. Equal angular is three congruent angles. What must they be? What does it have to be if they are equal angular? Lilia? 60 degrees. So all three are 60 degrees. 60 plus 60 plus 60 is 180. That is the only angle measurement we can have for equal angular triangle. If it is equilateral, it is equal angular. If it's equal angular, it is equilateral. They go together. Any questions on classifying our triangles? I'm telling you again, I always have kids mess up with side names and angle names. It asks for an angle name and they give me a side name, or it asks for a side name and they give me an angle name. Make sure you have written down the difference, which is the angles and which are the sides. And when it comes time for the test, take the time to check that you are doing it correctly. Every year I have kids writing down the wrong names. So they're not wrong in that, oh, it's an acute triangle, but if it was asking for sides, it does not work. All right, next objective. Field 55, I can solve for an unknown angle in a triangle or quadrilateral. Important to know, triangles equal 180 degrees. Quadrilateral equals 360 degrees. Again, I have people that say, yeah, I know that. Got it. I don't need to write it down. But on the test, I always have at least two people coming up saying, I forgot. Write it on your help sheet. It takes all of 2 seconds. Triangle equals 180. Quadrilateral equals 360. Super easy. Write it down quickly so you don't forget. When we are solving for those missing angles, we might need to remember things like our supplementary angles. Remember, or if we have congruent, if all three are congruent, we know all sides congruent, all angles congruent. If these two are congruent, they are going to be the same. Okay, so figure out what's missing. You take that 180, you take that 360, subtract out what you know, and look to see what you have to do with how many are left. For this one, remember we need to know the inside angles. So this angle right here is supplementary. So if we have 140 degrees, what does it mean if it's supplementary? Front and back of one card. So if it's supplementary, it's equals to 180. So if I know one part is 140, I know the inside angle would be 40 degrees. So now I know two of my angles. I can subtract them from 180 to find my last angle. Same over here. Use what we know about supplementary angles on those straight lines to find our inside angles, and then you can find your third angle. So you have to use some previous knowledge. Any questions? All right, next objective. I can use the Pythagorean theorem. What is our Pythagorean theorem? Lilia. A squared plus B squared equals C squared. So remember, you're gonna wanna put these on here. The legs are A and B. They form the right angle. The hypotenuse is the C and is across or opposite from the right angle. So the hypotenuse is always across from that right angle. The two legs A and B form the right angle. The C is always across from the right angle. What's going on? Do you guys have a question? Because you were just asking Bryn something, so is it something about math? Because I can help answer. Am I going too fast? Ava? Okay. So A squared plus B squared equals C squared. Two legs are A and B, they form the right angle. The hypotenuse is the C, and it's across from the right angle. Remember, when we do A squared plus B squared, in order to get it down to just the C, that's when we do our square root. So you can put that on there to remind you that once you add them together, you have to find their square roots. So you will want your calculator to find square roots tomorrow. Okay, any questions?
Do we need to know how many sides everything has?
Mm-hmm.
Oh.
Yeah, that's one of our objectives. That's this one. The next one, CO 57. We need to know the names of our different sided polygons. So you need to know, and I told you when I did this, you're gonna want to put this table on your help sheet because you will have questions that say, draw a nonagon. You need to know that the nonagon has 9 sides. Draw a concave heptagon. You need to know that 7 sides, at least one side is caved in. So yeah, you definitely need to know this. 3-sided polygon is the triangle. 4-sided is the quadrilateral. 5-sided is the pentagon. 6-sided is the heptagon, right?
No,
Hexagon, sorry. Hexagon. 7-side can either be called a heptagon or a septagon. I have seen it both ways. So you just need to know that they both mean 7 sides. One's Greek and one's Latin. Hepta and septa are both 7 sides. 8 sides is the octagon. 9 sides is the nonagon. 10 sides is the decagon. Madison.
I don't think any of us can put this under the card. I'm doing like the box.
Perfect. Yes.
I forgot the
I did not forget it. It's not going to be on the test. But you're right. 12 sides was on our homework. It's the dodecagon.
Can we have just like one more card just to write this?
Yes. Just for you, Madison, because you're being a good advocate for yourself.
What about me?
Yes, you too. I'm just saying because Madison was being a good advocate, I will allow a second card. Claire.
If you can you have like a
Like a 4x6 note card instead of the 6x5.
Yeah.
Oh.
I'm just gonna watch this.
Okay. Shh. So we also need to know not only the names of the sided figures, we need to know what it means to be regular, concave, or convex. So remember, whoopsie. Regular means that all sides are equal length. So if it's regular, all sides congruent. If it is concave, at least one side is caved in. Is making that inside angle be huge because there's a side caved in. Convex. Remember, convex is inside angles are all small. So I remember it as no cave-ins. The inside angles are all small. The way I remember, concave has cave-ins, convex does not. If you want to write the full definition that's in your binder, go for it. For myself, I just remember concave caves in, convex does not. Regular, they are all sides are congruent. Then we have CO58. I can determine whether the polygons are congruent, similar, or neither. So remember, congruent, they are equal. They're exactly the same measurements. Equal, same measurements. If they are similar, or they're same shape, same size. Another way to look at it. Same shape and size. To be similar, they are same shape, different size. Same shape, different size. And neither. They're not congruent. They are not similar. So remember to find it. Well, congruent's going to be easy. They're identical. Exact same measurements. To find the similar, look for the proportions. Of the sides. Are they multiplying up or dividing down in the same amount? So remember, you put the sides over each other, divide them. Remember, that's how we were checking for 59. Side over side, divide it down so you get the same decimal for each side, corresponding sides. So are they increasing or decreasing by the same amount? Are the sides proportional? If I put side A over side B, I divide it down to one decimal. Do each sides that correspond with each other divide down to the same decimal? If they do, they are proportionate and they are similar polygons. Any questions on that one? All right. PO 59, finding the missing side of similar polygons. If they are similar, we know that they are proportionate. So we go right to those proportions. Remember, we have those methods. long A over long B equals short A. I put A on top, I have to put A on top again. Oops, I have to write the right words for you. So long A over long B, short A over short B. Or I could say long A over short A. If I put long on top, then I have to put long on top for my B's. Now, this is a method. I'm going to add to the method to help us remember how to solve this. Remember, we do that cross multiplying. If this is my question mark, this is what I divide. Cross multiply the two numbers we know, divide out the other number, and you're left with your question mark. So if it went this way, if we have these two numbers, we multiply, divide, and you're left with that question mark. So you can add that to the method to help you remember how we solve for it. I highly recommend it. I always have kids say, well, I set up my proportions. How do I solve it? Give yourself a clue on your help sheet. Multiply diagonally, divide out your other number, and you're left with the question mark. That is all we have for our objectives. Please don't move. I am recording this. That is all we have for our objectives for this unit. You need to review and study. There's a lot in here, and I've had a lot of students say, oh, I'm not sure, I'm a little shaky on this test, I'm a little concerned and worried. Review it. Go over your objective pages. Go over those homeworks. I am after school tomorrow. I can do another review group because we will have had the practice test. So you can say, I didn't quite understand these questions on that practice test. Can you go over it with me? Take this test seriously. We don't want to have to do a lot of retakes. Try to get that good score right. But thank you to my friends who are sitting and listening like I asked. I am not talking for myself. I can take this test and pass it. This is for your benefit. Take the test seriously. Review your objectives, study, be ready for it. And if you want to stay after tomorrow, I am available. If you're watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.